Hello guys, welcome to Victory Science Hub. So in today's video we are going to be talking about differentiation at first principle using formula. In my previous video I explained differentiation at first principle, but we didn't use the formula. So in this video we are going to be using the formula to solve differentiation at first principle. We are going to start with writing down the formula. So dy for a function y which is equal to f of x, our, our dy over the x is going to be lim of change in x tending to infinity of f of x plus change in x plus minus f of x all over change in x. So for us to find our differentiation at first principle of this function, this is the formula we are going to use, and this is the formula that applies to solving all functions, to differentiate all functions. So this is also the same as lim of change in x tending to infinity of change in y over change in x. So what this is trying to say is that all this is the same as change in y over change in x. So now let's use this to solve equation. Suppose we have y is equal to x cubed x squared minus 1. Suppose we have this is a function, y is a function of x. Using that formula, our dy over the x is equal to lim of change in x tending to 0 of f of x plus change in x minus f of x all over change in x. So since this is a function, y is a function of f of x, so this is the same as this. So looking at this, we can say this is the same as this. So now we want to find our f of x plus change in x. For us to find our f of s plus change in x, what we just have to do is to, where we see x here in this function, we put x plus change in x. So this, using this function, our f of x plus change in x is equal to x plus change in x squared minus 1. So what we just did was that this is a function of y with respect to x. So here we have x, but in this case what we just did was to use this same function, but we change our x to be x plus change in x. So that is what we just did here. So now we have our f plus change in x. We are going to use the formula. The y over the x is lim change in x tending to 0 of, this is our function, x plus change in x square minus 1. This on its own minus x square minus 1 all over change in x. So this is what we have. Now what's left for us to do is to simplify. So our dy over the x is lim change in x tending to 0. Now we are going to expand this. Expanding this, we have x plus change in x times x plus change in x minus 1 minus x square minus 1 all over change in x. So this is lim change in x tending to 0. This times this, we have x square. This times this, we have plus x change in x. This times this, we have plus x change in x. This times this, we have plus change in x square minus 1, this one, minus x square minus 1 all over change in x. So now we are going to collect like terms. So we have lim change in x tending to 0. This plus this, we have x squared plus 2x change in x minus 1. No, plus change in x squared minus 1 minus x squared minus 1 all over change in x. So what we have, lim change in x tending to 0. We are going to open all brackets. We have x squared plus 2x change in x plus change in x squared minus 1 minus x squared plus 1. This minus times minus is plus all over change in x. So now we collect like terms. We cancel out the ones. That's cancelled. So this minus this will go. This minus this will go. So we are left with lim change in x tending to 0, 2x change in x plus change in x squared all over change in x. Now let me give you a tip. Once you finish simplifying and you get up to this point, for you to know if you are in the right track, you have to have change in x in all of them. Here we have change in x, here we have change in x. If you have the one that has only x in it, means that you made a mistake somewhere, so you have to go back. And this happens mostly for the numerator. Once you solve, you get to this point and you have only x in it, you have to cross check if you're really in the right stack. So now let's go further. So lim change in x tending to 0. Now we are going to divide to this, divide this will cancel, this divide this, one of this will cancel. So we have 2x plus change in x. That's what is going to be left. So our dy over the x is, now we are going to put our change in x to be 0. So we have 2x plus 0. So dy over the x is same as 2x. So this is our final answer. So now let me recall back. Using that formula, we have dy over the x of lim change in x tending to 0, f of x plus change in x minus f of x all over change in x. This is the formula we are going to use. So having a function, say y is equal to f of x. So when we have the function here, for us to find this, we just have to impute x there in the function to be x plus change in x. So anywhere we see x, we put it as x plus change in x to find this. So when we find this, we now subtract this from this and divide it by change in x, and we simplify everything till we get to this point, and we now divide by change in x. When we are done dividing by change in x, we now put our change in x to be infinity and we get our answer. So that is just it. Is very, very easy. Thank you for watching this video. Please don't forget to like, share and subscribe. See you in my next video.